a 10 megawatt Adelanto solar project completed in 2012. Thomas is a licensed structural and civil engineer, holds a Master's of Science degree in civil engineering from the University of Southern California, and is a Bachelor's of Science degree in civil engineering from California State University, Los Angeles. Let's give Thomas a warm welcome.
Thank you, Paul. Thank you, Eric, for a very fine presentation. And thank you all for coming this morning, making time out of your busy day to come down here and hear us talk about our little projects over here up in the Antelope Valley and north of that. For what is a very important part of the department's strategy going forward in future years as far as where we get power, where we're required to get power from. And so what I'm going to focus on are the solar projects themselves. And as Eric pointed out, these projects all tie in, and the green energy, the solar energy that comes from those projects relies on the Barron Ridge transmission line to bring that home to our ratepayers and to power our city. So the presentation is going to cover the Beacon Solar Power Plant. The Beacon Solar Power Plant includes the Beacon Collector Station, the Beacon Solar facilities themselves, and those are set through what we call power purchase agreements. If you aren't familiar with that term, or you heard PPAs. The power purchase agreement is where a developer builds the facility, operates it, and what we do is we buy the power from them. They essentially are a generating company, and we simply take the electrons that they produce. Springbok is another PPA, and that is Unit Energy is the company there. Recurrent Single Solar Project by Recurrent Energy, and that one actually ties in over the Barron Ridge Station. So we'll talk a little bit about that as well. And as I mentioned, the Beacon site has Hecate/S-Power. They're partners in 60% of the development of the site, and Sun Edison is developing the other 40% for a total of 250 megawatts out there. The department has very specific renewable energy goals, and you've probably heard about these as well. You know that we're required to have a certain percentage of the energy we deliver to our customers to be sourced from renewable energy, which includes wind, solar, biomass, geothermal, low-end hydro. The goals that were set, they've been continually advancing and increasing. And at one time we were talking about 20% was the goal in California. Well, we achieved that on average between 2011 and 2013. The Adelanto project was actually completed in 2012, and that was part of that effort and that goal. That project itself took a number of years to actually bring to fruition. And so these goals that are set out before us, we have to start well in advance of them in order to actually meet them by the time that they're due. And so December 31st, 2016 is the deadline, our milestone for getting the 25% mark. And so the projects that tie in at Beacon are part of that goal itself. And then we have the future goal in 2020 to get to the third. And you may have heard that California is actually moving in the direction of legislating even higher goals for that. And by 2030, we may be looking at 50% of our power. So renewable energy is a very big part of the department's future. And if you're just coming into your career here at LADWP, keep that in mind, because a lot of the stuff that you do in one way or another is going to tie into these renewable energy projects. Eric Montag's project is a transmission line project. We've done transmission line projects for years and years. We know how to do that. That's our bread and butter. Come in here as a power engineer. That's what you study. That's what you do. But the new wrinkle in all this is we're tying into these new efforts, these new generation sources. So it's kind of like old becomes new again. So the Beacon Solar Power Plant, as Eric mentioned, it's the largest solar power plant in the LADWP family of power generating facilities, I should say, from the solar family of power generating facilities. The overall site is a 2,500 acre site. You can see it right in here. It doesn't look like 2,500 acres because the scale is kind of large, but you can see its relation to the Barron Ridge Station. the transmission line. This is Mojave down here. Highway 14, up in the hills, mountains really. Pine Tree Wind Farm, and this little rectangle here is Pine Tree Solar. That's just under 10 megawatts. This isn't the scale, but this is 250 megawatts. Quite a jump in there. And sometimes we talk about renewable energy in terms of what is the equivalent in terms of homes and rooftops and cars off the road. So when our public affairs folks put together something out for the public, a lot of times we're talking about an equivalence of how many homes are being powered. If you would imagine that the average typical consumption of one of our customers at their home, that would be the equivalent, then this project at Beacon, just the projects there at the site, are the equivalent of about 127,000 homes. Here's a closer view of the 2,500 acre site. There's 5 sites within the Beacon solar property. I mentioned about our PPA developers that are working with us. So Sun Edison is one of the developers, and they would be building Site 2 and Site 5, and Hecate Power are building 1, 3, and 4. We're building the collector station over here. This is the substation, and the transmission line, and Barren Ridge is down in here. 14 is over here, and Pine Tree is up here in these mountains. There is a, sometimes people ask, is there really a river here? This is probably a good time to talk about the environmental. As Eric pointed out, the area is subject to environmental constraints, namely the desert tortoise is our concern, but there are other species there. Mojave ground squirrel is a concern. Desert burrowing owl is a concern. Desert kit fox, a whole host of plants and other animals that show up on the EIR. But desert tortoise is the one that we really need to be concerned about in terms of how it affects this project in terms of bottom line dollars. The reason I say that is because this boundary of the project here has approximately 12 miles of special fence. What makes it special is at the bottom of this 8-foot-high security fence, we'll put the barbed wire on top there, just like we usually do around power plants. At the bottom is a section of smaller smaller size fencing that's designed to keep desert tortoise out from this entire area. So before we could do any of the work in here, we had to clear the area. What that means is have qualified biologists come through and walk through this entire area and determine whether there were any desert tortoises. And if there were, track them. Then we start setting up the perimeter. And when we're all done, survey it again, make sure they're all out. And by the way, we can't move them. We have to let them go out on their own. That's a little wrinkle in the way that we approach the incidental take permit. There's a difference between the state, California state incidental take permit, and a federal incidental take permit. We have the state incidental take permit. That lets us clear the area and allow for tortoises to come out on their own. We can't actually move them. That would be another permit. So we did manage to clear it off, and incidentally, we did do this in stages. So that once we started the station, we had a boundary around that, the special fencing, and then we worked our way out. And finally, in conjunction with our developers, we were able to get that 12 miles of special fencing in there. This river-looking thing here is under jurisdiction of the state, because it's considered the state waters. And so, in order to do any work in here, we run into the other permit that Eric mentioned, which is the stream bed alteration permit. In order to construct this site and to have future operation of it, there needs to be some roadways in here. You see this slightly green line in there. So these roads, you can figure right in here, and this little area in here as well that's subject to the stream bed alteration. We need to get a permit in there in order to put in the roadway and to make it possible that when this floods during flood stages, that it won't get washed away. Incidentally, we have had some rains. Not a whole lot of water that shows up there typically, but this blue boundary here is the extent of the FEMA, Federal Emergency Management Agency, boundary for the 100-year flood. All right. Let's talk about how we get this energy home. So here we have the Beacon Collector Station. This somewhat purple line in here is the Beacon Barron Ridge Dentai line, the 230 kV transmission line, about 3 miles. You come across over to near Highway 14, run south, cross it, and then continue on down to connect into the Barron Ridge switching station on the expansion side. This red line is Highway 14. Another one of our constraints on the site is this curved line in here. That's the Union Pacific Railroad. You won't believe how much trouble it is to work around this right-of-way. It's another huge agency. It's a 300-foot wide easement that we have to deal with here. It changes in dimension here to 200 width, but it's a significant amount of land that we need to traverse with our road. We have to cross the transmission line. This site over here, site 5, has to connect into the collector station before it transmits its energy into our system. So we have 34.5 coming, 34.5 kV, 34,500 volt circuits coming across the Union Pacific right-of-way. So that's what this curved line represents. That's part of the reason why, if you look at the earlier slide, that this is broken up into different segments, is because of all these constraints in these different sites. The other reason is that we wanted to have the ability to award to different contractors, not just one single contractor for the work. And so through the process of the evaluation and the award, initially we did have 5 different developers, and through the process of negotiation, it just happened to be that it narrowed down and resulted in just 2 developers. But the initial intent was to have as many as 5 different developers and to provide some diversity in our contracting out. It's also a little better when you kind of don't put your eggs all in one basket. So we've got 2 baskets basically. Something seems to have happened to my graphic here. What it was supposed to show was the initial grading for the collector station. This yellow line on here is the boundary of the Beacon site. And this area in here is where the collector station is. You can't really see that, I'm just going to move on. But one thing to note is that the site originally was an alfalfa farm years and years ago. It hadn't been used for a long time. It's an abandoned alfalfa farm. And so it's already considered a historic area, which helped us as far as the environmental process. Nevertheless, legislation introduced protecting the desert tortoise made it necessary that we would consider that it's a desert tortoise habitat. We're spending good money to comply with these environmental considerations. In fact, that desert tortoise displacement is something we have to deal with by actually going out and reserving or purchasing, if you will, a certain amount of land to offset and provide equivalent habitat. I won't tell you how many millions of dollars that's involved, but it's a big amount of money. All right, so now we actually get to the engineering kind of work that us civil engineers like to look at, and that's starting to move dirt. So this is the initial main road grading. We had to remove sections of dirt where it was, the soils were poor, then backfill them back in, compacting in. There was a lot of site preparation. You can see that the site has the natural desert scrub out there. So in order to do the work, we clear and grub that. And then I mentioned desert exclusion fence, desert tortoise exclusion fence. So off in the distance there isn't one in this picture. Later on, you might see some photos of it. We would have to put a fence out there in order to enclose that area. Dust mitigation is another one of our environmental considerations out there. And in order to do that, run water trucks out there, keep the soil damp and wet it down. This area right here is where we're grading for the future collector station. There are also areas that we're bringing a lot of material in to build a collector station. when the solar fields actually get constructed, they'll also bring in a lot of material. So unlike here in the basin where you might have a project and construction needs to stage their material, they may be able to keep it in stores, they may keep it at a Truesdale facility, warehouse. Out in the desert, we don't have any place. So we need to set up these lay-down areas, these yards, fence them in, and places where all this material can arrive, be delivered to, and then the construction work can proceed along. Another early part of the work is we need to have construction power. So very early on, we start talking about the 34,500 volt circuits that need to come in order to bring the energy from the solar fields into the collector station. There's an existing 12,000 volt Southern California Edison service that we can tap into for our auxiliary power, and the future telecom and data needs as far as how our site was going to work. So we went ahead with the plan to install these poles in here for the service. That would provide ability to bring 480 volt service to our construction trailers. There's water pumps for water wells that need the power. And this is a desert environment that gets up to 110 degrees or more in the summer. So for safety reasons and for just being able to work, very important to have air conditioning facilities in there. If you're working in that kind of environment, heat stress is a very important consideration, and a place to cool down is a necessary safety item. Now we start getting into a little bit more construction. These are the rebar cages for some of the piers that are being installed to support the construction out there. I believe that these are anywhere in the range of 40 to, I forget what the longest ones were, we're up to about 65, 66 feet. Yeah. These are very deep footings out in that desert environment. The soil is virtually just sand. So in order to get enough bearing or support for the equipment, these very deep footings need to be designed in place. Actual station construction started May 2014 with the excavation, recompaction, and grading, and then excavation for footings, and the material deliveries, as I mentioned, also started at that time. Here you see an auger for drilling the deep drill pier foundations, and in the foreground you can see already the rebar and the dowels that stick out of the surface here, where the rest of the footing is going to tie into. The rebar cage that I showed you in the earlier picture, that's what's down in here into the soil. And in a later picture, you'll see some of the pads that are poured around that. As I mentioned, the heat stress issues at the site. This construction was going on in May and June. And so one day that I was out there, I think my thermometer said it's 113, 114 degrees. So it can be easily 110 degrees. It gets windy out there, so now you not only have the heat, you also, it's like a blow dryer, just drying you out. So safety is a very important issue. You can see that all the folks that are working out here, they're wearing plenty of covering on them because they got to protect themselves from the sun. Here's one of the pads right here. This is a transformer pad that gets tied into pier footings that were poured before that. These rebar cages are very heavy, so lifting considerations. There's a lot of safety issues that these crews need to be considering on the site as they work through this. In order to place the concrete, it's a high-level pumping operation. Concrete gets pumped from a concrete truck and gets set down way over here. This fellow right here, it's got a remote type of control unit here, and he's actually controlling a lot of this work. Now let's look at the quick station diagram just so we kind of get oriented here. So the station plan here labeled some of the things that are more specific to the project itself, and the electrical engineers is probably all they have. But the Beacon Road, the main road is over on this side over here, on the left side of the diagram. The control house is over here on the right. And this is a concrete block building with a roof. And you see here there's a duct that comes out of the building. You'll see a picture of that later. And then there's equipment. So the solar arrays are completely around this station site. But they come in from the east. The circuits all come in from the east into the 34,500 volt equipment or 34.5 kV equipment. And there will be circuit breakers in here and on switchgear. Then there's another project that's coming in at 230,000 volts. So that doesn't come into this section, it comes right into the 230 kV section. The 34.5 is stepped up to 230,000 volts. That gives it more efficiency. You folks in the water system remember the analogy between electricity and water is that voltage is analogous to pressure. So by pressurizing the electricity, if you will, then sizes of conductors go down, you get more efficient, you get less loss. And so it comes up to 230 kV, and at this point on this side of the station, it's ready to go into the Beacon Barron Ridge Gen-type transmission line that makes this 3+ mile trip all the way to Barron Ridge Station. There's a single line diagram, basically shows the same thing. But this is what you see as a schematic of what the station is. I mentioned about the cable trench coming out of the control house. This is what a cable trench looks like. You have conduit or cable. And once the cable enters the cable trench, this provides plenty of circulation with cooling cables and more reliable operation. Before the construction can go on the site, it's necessary for safety reasons to have grounding throughout the station. And for that, a grounding grid is set up in the station. These right here are circuit breakers. These are the 34.5 kV circuit breakers going onto their foundations. At this point, they don't have the bushings up here that you'll see. There was a picture that Eric had that had a completely assembled circuit breaker. The control house in progress. Here's the rebar or reinforcing steel for the inside of the walls. And then the concrete block, this is being laid. Eventually it's going to get up to here and get a roof on there. The 34.5 kV to 230 kV step-up transformer was delivered in October of last year. This is the transformer pad that we were talking about. When the transformer is delivered, it's delivered in this manner. It doesn't have a lot of the other equipment you usually see in the station. That'll be assembled onto it over the next even weeks. Radiators, all sorts of controls, the bushings, all that is necessary to be installed and tested before it can actually be put into service. There's 2 of these over at the collector station. Here's some of the underground conduit and its interface into the cable trench. Again, 34.5 kV breakers. Here's some transformers here sitting on their pads. This is 34.5 equipment. So this is the interface to the solar, which is on this side of the cable connections in are from this side. But all around this station site, there's going to be solar in there. 230 kV switchgear is not in this picture, but it's on the opposite side of the station. Here's the control house in progress. You see the roof frame going in. This room right here, and in the next picture, is now filled in with electrical equipment going in. Safe blocks in here, you have some load center panels back in here, and in this area where they're currently working, you'll have panels, control panels, relay panels, and other equipment out of the window. So this station's going to get all of them. You see the overhead cable tray in here. There's a lot of work that the electrical mechanics need to work in order to get the station all completed. This is an overview of the sites again, but now showing the generally representing where the 34.5 comes into the station. So we have crossings. This is all overhead. There are a couple sections where we do go underground, and those all come into the station. And then once in the station, then they'll go on to this thin in this diagram, thin line diagram for the 230 kV gen type. Each site, it's roughly, we'd say 50 megawatts each, but really there's a little variation depending on the amount of space that's actually within each parcel for the total 250 megawatts. This solar module behind me is actually a smaller one than the ones that the developers are using out there. This one is probably about a 75-watt module. But the ones that are typically installed there are 250-watt modules. The ones out here at the JFP parking lot, they're on this scale here. But the 250-watt modules, if you will, we're talking about 1 million solar modules being installed out there in the desert. I lose the ability to count at that point. It's just a lot. One of the developers gave us a quick view of one of their finished sites. So this is actually the way that the site is going to look, very similar to this, with what we call single-axis tracking solar modules. This is a picture of our Atalanta installation. These are static, these don't move. The ones over at the beacon, they're going to actually track the sun, and it gives them about, on the average, about 50% more energy every year. So a lot more efficient. As I mentioned, it's a power purchase agreement with the developers. It's an agreement for 25 years, and there's options for DWP also to purchase the facility. The way that power flows in the solar array field, this graphic sort of not agreed once they got into this format, but solar energy comes into these sections here. These are all very modular, repeating sections. These are inverters along with a transformer, and then they go into switchgear, and then it goes into what we call a point of interconnection. Really quite a simple arrangement, pretty straightforward, just repeats and repeats. Here you see solar modules being assembled, mounted with the DC circuit, string circuits. Those go into what are called combiners, just combine all the DC circuits together, and then wiring goes into the inverter equipment. This is a typical inverter. This could be at the point of interconnection, or it could be through some additional switch. 10 megawatts. Beacon is 25 times this size. This is along the converter station right back in here. This is the switch yard. So it gives you a scale, and there's 45 acres of land in here. You see in here, these small square rectangles, those are each inverters. So multiply that by 25 times, and you start getting a feel for how large the Beacon project is. The additional projects that tie into Beacon, just real quickly, there's a 100 megawatt project called Springbok 1, another 150 Springbok 2. They're going to have their own transmission lines tying into the Beacon collector station. And so altogether, with those projects, that's 500. You can see here, this is 14. These are the Springbok parcels. Here's our Beacon site, and then the transmission line coming down to the Barron station. There's just some facts and figures. I'll skip that real quickly because I want to mention the other project that's tying into the total of 560 megawatts into Barron station. So we have 500 coming in from the north, and then we have another 60 coming in from the recurrent energy project called Recurrent Cinco, along with its own transmission line. 60 megawatt project, about 29,000 homes. So altogether 560 megawatts, and somewhere on the order of about 7 to 8% of DWP's renewable energy needs are going to come from those 3 projects that I mentioned. As we talked a little about earlier, the teams that support these projects tend to be very large, and everybody that is involved in these teams has an important contribution to them. And it started just listing, and it just went on, and this could go on and on because there's so many people, but I just wanted to put at least some names up there because in major projects, of course my team, but I've had quite a number of our new engineers come through, and I did want to take a moment to thank for the short time that they were with us in major projects, and they rotated different groups within the department. They got a chance to be a part of this project team as well. So thank you very much for that. Everybody's up there. I want to thank my student engineer that helped me put this presentation together. He's actually gotten hired by somebody else, but he's interviewed to come back to us. So kind of good, kind of bad that we lost him, but kind of good that he's got a job in the student engineering program experience. And just want to thank everybody that is contributing to this. And that is just kind of like an overview of what I mentioned before. So thank you. And I know that we're out of time.
Everybody running to lunch. What's up, Sam?